Okie dokie. So let's take a look at this problem, which we're going to solve using substitution. So first thing we always check to see is one of the equations isolated. And so if I look at my top equation, the answer is yes, this equation is isolated because we have y by itself on one side and 6x minus 11 on the other. So we would say that y is isolated. So since it's isolated, we can just jump right into solving by taking the top equation and rewriting it, but using y, replacing y with 6x minus 11 instead. So essentially what we're doing is we're taking the y of the equation out and replacing it with the 6x minus 11 from the top equation. So we're just substituting that in. That's why we call it substitution method. So from here, now we can solve. So we draw our line, we go through our checklist. Do we have to distribute here? The answer is yes, we have to distribute -3. I say -3 because the minus sign, to 6x and to -11. And so that's going to give me -2x minus 18x plus 33, right? -3 times -11 is a positive. So plus 33 equals -7. Then my next step is to combine like terms. So I've got -2x and -18x, which give me a total of -20x. And then I ask myself if the variable's on one side, which it is. So my last part is to just solve the remaining equation. So I subtract 33 from both sides, and then I'm going to divide both sides by -20, and I get that x is +2. But I'm not done because I still need to know the y coordinate of this point. So I'm going to take my isolated equation. So I'm going to take the one from the top, and I'm going to plug in 2 for x. So that's going to give me y equals 6 times 2 minus 11, which is 12 minus 11, which is 1. So my final answer should always be written as a coordinate, and it's going to be 2, 1. Let's do one more problem where y, or the variable, is not isolated. So if I look at this system in number 9, neither equation has an isolated variable, meaning neither equation has y or x by itself. Now when I decide which equation to isolate the variable, I want to look at the one that's easiest. So I want an equation where it says either x or y. And so the best equation to do that for would probably be this top one. Because see how I already have just a plain y? All I really need to do is get rid of this -5x, and then I will have something with an isolated equation. So let's take this guy, and let's go ahead and work with it over here. So I'm going to take -5x plus y, and I'm going to get y by itself by adding 5x to both sides, which gives me y equals 5x plus 2. So what I wanted to start this process is something where y is isolated, where y is by itself. And now I have just that. I have y on one side and 5x plus 2 on the other. So then now I'm going to take what I just got and I'm going to substitute it into my second equation. So I'm going to do -3x plus 6. Now instead of y though, instead of using y, I'm going to replace y with 5x plus 2. So I'm going to use that equation that I just got to put in 5x plus 2 for y. So I just took this and substituted it into the parentheses. So now I go through my checklist to solve. So I ask myself, is there anything to distribute? Yes, I have to distribute the 6. And so I get -3x plus 30x plus 12 equals -12. Then I have to combine my like terms. So those add to make 27x. Then I have to get rid of the plus 12 by subtracting 12 from both sides. Oh, sorry, I'm just noticing a mistake in the middle of my work. So this actually, in my original equation, had been -2. I dropped the negative sign by accident. So that should have really been -2. So right here, this should instead be -2. So this is -12, which means I'm going to be adding 12 to both sides. I did this problem earlier. That's why I knew I had made a mistake. And so -12 plus 12 is 0. And I'm going to divide both sides by 27, and I get x equals 0. And so now my last step is to find y. So I'm going to take my isolated equation and plug in 0 for y. So 5 times 0 is 0, minus 2 is -2. So my final answer is 0, -2.